What if hackers could silently redirect all your network traffic to their computers? With ARP spoofing attacks, they can, and most networks are completely vulnerable. But there's a simple Cisco security feature that stops these attacks cold. Dynamic ARP Inspection, DAI. In this video, I'll show you exactly how to configure DAI to prevent man-in-the-middle attacks. Plus, reveal the critical mistake that could block all your legitimate traffic if you don't set it up properly. Dynamic ARP Inspection, DAI, helps prevent ARP spoofing attacks, which leads to the man-in-the-middle attack. It is a security that allows you to validate ARP packets in the network. To do this, it uses DHCP snooping to verify that a MAC address has obtained its IP via the trusted DHCP server. That is, a reliable DHCP. We'll see how to set it up. Here's the topology we'll use. We have a total of 4 devices. The router on the left is a host that will be a DHCP client. The router on the right is the DHCP server. The top one is the router used by the attacker. And in the middle, we have a switch that's configured for ARP dynamic inspection. We will start by configuring the switch, adding all of its active ports in LAN 10. Now that we are sure that these ports are part of the same VLAN, we can configure DHCP snooping. The IP DHCP snooping and IP DHCP snooping VLAN 10 commands enable DHCP snooping in general, i.e. on all these interfaces. The No IP DHCP snooping information option command is used to disable the insertion of option 82 in DHCP packets. Remember that in some cases, by enabling DHCP snooping, clients may have trouble receiving the DHCP server configuration, so this option is disabled. To continue, you must not forget to trust the interface that connects to the DHCP server, that is to say, on the 03 interface, with the command IP DHCP snooping trust. From now on, our switch will keep track of these DHCP messages. So, we're going to switch to the router on the right for a configure an IP and declare it as a DHCP server. It is assigned the IP 192.168.1.122.54 on its 0 interface with the command IP address. The IP DHCP pool command is used to give a name to the DHCP pool. And with the network command, we add the IP range, which the DHCP server will assign to the hosts. We will now see if the host can obtain an IP address from the DHCP server. The IP address DHCP command will enable DHCP on port 0ZS on the host. After a few seconds, we will be able to see that the DHCP has assigned it an IP, which is in the example 192.168.1.01. Out of curiosity, let's take a look at what the switch has stored in its database of DHCP snooping. With the show as IP DHCP snooping binding command, we can see our entry, which contains the MAC address and the IP address of the host. We are now ready to configure the dynamic inspection of the ARP, which can be configured by the way with a single command. The command IP ARP Inspection VLAN and the VLAN number. In the example, this is VLAN 10. From now on, the switch will check all ARP packets on untrusted interfaces. Remember that by default, all interfaces are non-trusted, i.e. non-reliable, except for the one we just configured and which leads straight to the legitimate DHCP server. Now we're going to check if it works. To do this, we'll configure IP 192.168.1.2 on the host, which will attempt an attack with the command IP address. And we will try to ping from the attacking host to the DHCP router. We can see that the ping doesn't work. So, let's go and see what thinks the switch. As can be seen from the switch logs, all the attacker's ARP requests have been abandoned. The switch checks its ARP table and compares it with the information in the DHCP Snooping database. Since it does not see any matches, the packets are therefore dropped. The Show IP ARP Inspection command allows you to see the number of dropped ARP packets. So that's all good, since the attacker was able to be stopped. But on the other hand, since the implementation of the ARP Dynamic Inspection, we have another problem. Before we see that, let's go close the attacker's port by shutting it down. We will now see what happens when we try to ping from the host to the DHCP router. The ping doesn't go through. So why, since its activation, can the host no longer access the DHCP server? If we look at the switch, we can see that our ping has generated error logs. From these logs, it can be inferred that the switch is suppressing ARP responses from the DHCP router to the host. And suddenly, since the DHCP router has no idea how to reach the host, then the ping fails. To analyze the situation in more depth, we will run an ARP IP show on the host and the DHCP router. So why doesn't the switch process the ARP response? Well, the problem is that the DHCP router uses a static IP address. Dynamic ARP Inspection checks the DHCP Snooping database on all untrusted interfaces. That is to say, not reliable or not trusted. The 03 interface of the switch is reliable on the DHCP Snooping side, but not on the ARP Dynamic Inspection side. This is why the ARP packet is deleted. To solve this problem, there are two solutions. Either create a static entry for the DHCP router, or configure port SO3 of the switch as a trusted, i.e. reliable port. So, let's look at the two solutions. We'll start with the first one. First, we will create on the switch an ARP access list, which authorizes the IP address and MAC address of the DHCP router. Then we will apply it to the dynamic inspection of the ARP with the command IP ARP inspection filter, followed by the name of the access list, then the VLAN number. With this configuration, the switch will first check the ARP access list, and when it does not find any match, then it will move on to checking the DHCP Snooping database. If we restart our ping, it should work. The other way to resolve this issue is to configure the 03 interface of the switch as trusted by ARP Dynamic Inspection with the command IP ARP Inspection Trust. Dynamic ARP Inspection allows all ARP packets on trusted interfaces. That is to say, trusted. Before we finish the course, we're going to quickly talk about the IP ARP Inspection Limit Rate command. By default, ARP traffic is limited to 15 packets per second on non-trusted, i.e., non-trusted interfaces. In the example, we go from 15 to 10 packets per second for the 0 means on BSR 1 interface. And the last thing we're going to see is the IP ARP Inspection Validate command, followed by a question mark. This allows for additional security controls. DSTMAC allows you to check the destination MAC address of the Ethernet header against the target MAC address of the ARP packet. IP allows you to check invalid IP addresses. For example, the one in 0.0.0.255.255.255.2 or multicast addresses. And SRCMAC allows you to check the source MAC address of the Ethernet header against the MAC address of the sender of the ARP packet. So, it is possible to activate only one of these options at the same time. For example, if we want to enable verification by destination MAC address, the command will be IP ARP Inspection Validate DSTMAC. And that's it for the dynamic inspection of the ARP. This is a very nice security feature, but make sure you have ARP access lists configured for all devices with static IP addresses before enabling it. Otherwise, most of the traffic will be blocked as soon as it is activated.